Good morning, it's Mr. C back with your level 6 math. Today we're doing Saxon Math lesson number 16. This is rounding whole numbers and estimating. Now this is a lesson that is super important because this is going to make your life so much easier and so much better. If you get good at rounding and if you get good at estimating, you're going to be able to calculate things really quickly in your head. And even in math this year, as you go through the year, this is a great strategy for checking your work. So this is just a foolproof method for ballparking whether or not you're in the right area. And so we need to know how to round and estimate. It's so important. So we're going to round numbers to the nearest 10, 100, and 1,000, but of course we can round to bigger numbers if we need to. And this is going to help us estimate to answer a problem and use estimation skills. Super important. So with rounding means reducing the digits in a number while keeping its value similar. It's not going to be exact, it's rounding. Okay, the result is less accurate but easier to use. This is a common method to decide the last digit to keep. So we'll often just round the last number, especially if we're doing a decimal point and the decimal goes on for forever. At some point you have to decide how many decimals am I going to keep, and leaving it the same if the digit is less than 5. Oh, sorry, I missed this one. Increase it by 1 if the next digit is 5 or more. This is school rounding. In the real world, you usually round down because you want to be conservative, especially when it comes to money. You want to make sure you have extra money, not less than money. And so this is a little different in school, but in school, anytime we have 5 or more, we round up. Anything less than 5, so it might be 4.9999, then we would round down. All right. An example, 243 rounded to the nearest 10 is 240 because 3 is less than 5. So it totally makes sense. I know a lot of you have already done this or you've been doing this for a long time, but this is a good time to talk about it again. When we round a whole number, we're finding another whole number, usually ending in a 0 that's close to the number. So if we start here with 667 and we're going to round to the nearest 10, then 7 is higher than 5, so we're going to round up to 670. Now if we wanted to round to the nearest 100, we'd look at the nearest 50. If 67 is higher than 50, so we'd round up and it'd get us to 700, not to 600. Okay? So let's round 6,789 to the nearest 1,000. So if we're looking at thousands, the number that matters is the one next to the 1,000, which is the hundreds. And if it's higher than 5, we round up. 7 is higher than 5, so we'll round 6,789 up to 7,000. Yay! All right, 550. Now this one's tricky. To the nearest 100. Now remember, if it's 5 or higher, so if we're going to the nearest 100, we start at the hundreds and we go over to the tens column. We go to the one next to it. That's what we're rounding. And if it's 5 or higher, we round up. Now this is exactly 5. So 550, even though it's exactly in the middle between 500 and 600, we're going to round that up to 600. Okay? If you rounded it down to 500, you'd still be just as close, but in school, we always round that up. All right, rounding helps us estimate the answer to a problem. Estimating is a quick way to get close. And again, this is so good for checking your work. If you want to see if your work is close, you just estimate, and it works really great. We'll also see in the example problems that you often estimate when it comes to money. Because if you're just trying to figure something out really quick, do I have enough money? Do I not have enough money? Estimating really helps you get there fast. We can do this in our normal work. Like if I'm asking a question in class and I want just you to ballpark it to see if you're close, I might just ask you to estimate. Okay? So estimate the sum. Sum, remember, that's when you add things together. 467 and 312. Now it doesn't say round to the nearest 10, round to the nearest 100, round to the nearest 1,000. And we would get different answers depending on what we're rounding to. So for example, if we rounded to the nearest 1,000, this would be 0 and this would be 0. So the sum of those two together would be 0, which isn't going to be helpful. Typically when you think of rounding, you want to think to one digit below what it is. So we wouldn't round to the nearest 100, maybe we'd round, or never mind. Scratch that, go back. We round to whatever the highest denomination is. So here we'd round to hundreds, right? Because these are both hundreds. So this one we would round by using the next to last digit. So 6 is higher than 5, so we'd round this up to 500. 1 is less than 5, so we'd round this down to 300. So we're really looking at 500 plus 300 equals 800. And this is something you should be able to do really fast. If you practice, you can just look at that and be like, oh, that's close to 500, that's close to 300, 500 plus 300, 800. So when I add these together, the final answer is probably going to be pretty close to 800, give or take 50, because we're rounding. So we rounded 500, round to 300. Now if we add this really quick, 7 plus 2 is 9, 6 plus 1 is 7, 79, 4 plus 3 is 7, 479. 479 is not exactly 800, but it's pretty close. So when we estimate, again, that's a good way to check our work, is we just think, oh, we added 479, and then I'm just going to estimate really quick, 500, 300, 800, is 479 close to 800, or sorry, 779 close to 800, yes it is, so it checks out. All right, let's try this again. I love this one because this is a real problem. We do this all the time. Stephanie's going to the store. She has a $10 bill and a couple of quarters. She needs to buy milk, which is $2.29, $4.78 for her cereal. That's expensive cereal. She must be getting like the Raisin Nut brand. Good for her. All right, an orange juice for $2.42. So these are random prices. I've never seen juice for $2.42 at the grocery store, but we're doing math here, and Saxon Math does math a little crazy. That's okay. Does Stephanie have enough money to buy what she needs? Now, typically we factor in tax, and taxes will be anywhere from 0 in some states where you don't have a sales tax to as high as 7 or 8%. That's why we want to estimate. We want to see if we're in the right ballpark, because then we can think tax, it's going to be, for $10, it's going to be less than $1 probably. So let's just estimate. $2.29, that's close to $2. $4.78, that's close to $5. $2.42, oh, that's about $2.50, but we could go to $2.50 or we could go to $2. So if we do 2 plus 5, that's 7, plus let's say $2.50, that gives us $9.50. If we got $10.50, that's going to give us enough for tax. Okay, so it's probably good enough. Milk and juice are going to be $2.50 each. So she said she rounded this up to $2.50. She rounded that up to $2.50. And if you're rounding up when it comes to money, that's going to help you be more conservative, which is a good idea. And then her cereal's about $5. So all three items is going to be less than 10. It's pretty close to 10. And if tax is not charged on food, she has enough money. Even if it is charged, she probably has enough money. Okay. Let's look at this graph. According to this graph, more people lived in Ashton, population of Ashton, 1970 to 2000, in 2000 than 1980. Oh, it's a question. About how many? So in 2000, if we go, let's see, between 6 and 8, that's 7, and it's in thousands, so about 7,000 people lived there in 2000. In 1980, it was only about 4,000, so they're growing a lot. That's almost doubled. 7,000 minus 4,000 is 3,000. That's an easy one to estimate, because these are pretty close to, it looks like it's exactly 7,000. Of course, these numbers are probably estimates. All right, so this is a subtraction pattern. We subtract 4,000 from 7,000, and we get 3,000 more people. Okay, so just like in our last lesson where we said more people or fewer people, it's important to say there were 3,000 more people in Ashton than 2,000. That's it. That's our lesson. So good luck with it.